In this video, I'm going to show you how to graph hyperbolas. Okay, function hyperbolas are not functions, so let me take out the word functions. Okay, let me look forward here. Okay, let me use this one. So it doesn't have all this information on here, so because it's not a function. Okay, so a typical hyperbola, really the function looks very similar to an ellipse, but the key difference is there's a subtract sign here in there. So y squared over 4, and just like an ellipse, we need to make a 1. Okay, so we could actually change this around to show you how to figure out some points. And this is not what I would actually do when you're graphing it, but I'm going to go through this and show you. The least common denominator of 4 and 9 is 36. So if I multiply both sides by 36, I get this. I change this around to where it says 36 divided by 9 is 4. 4x squared minus, now 36 divided by 4 is 9. 1 times 36 is 36. Okay, if I subtract 4x squared from both sides, I get a negative 9y squared equals 36 minus 4x squared. And if I divide both sides by a negative 9, I get y squared is a negative 4 plus 4 over 9 x squared. And if I do the square root of both sides, okay, I get y is plus or minus. Now I'm going to reverse these two. Looks this be a little more comfortable for me. Alright, so what would I pick for, and I'm doing this to show you what would I pick for x. Okay, so what would I pick here to an easy x? Okay, alright, I see that 9 in front of that 4 over 9 in front of x squared. So if I pick x to be a 3, okay, 3 squared would be a 9, and that 9 divided by that blue 9 would cancel out. So I would have plus or minus the square root of 4 minus 4 plus or minus, of course, 0, which is 0. Okay, so if I pick 3 for my x value, I'll get an answer of 0. Same thing, because x is squared here, I'll get the same answer if I pick a negative 3 and square a negative 3. I also get a positive 9, which will cancel out that blue 9 underneath that 4/9. I still have a 4. 4 minus 4 is 0. Alright, so if I pick a negative 3, I also get a 0. Alright, and really that's it. Okay, I really struggle picking another x that would really be nice to work with. If I try to pick something like a 0, which I would do with an ellipse, okay, this part becomes 0, but unfortunately I have a square root of a negative 4. Okay, so I can't pick 0. Okay, in fact I can't pick anything between 0 and positive 3 or negative 3. I could pick values that are more than positive 3 or values that are less than negative 3 and get answers, but those would be, you know, kind of bad, hard to graph answers, so I'm not going to pick those. So that would be my two spots. Okay, so 3, 0 and negative 3, 0. So I'm going to write those just to save us, just so. And I'm going to erase this because when I graph hyperbolas, I don't really ever do those. Okay, this is what I do. Really similar to the let me put the function back up here. We had x squared over 9 minus y squared over 4 equals 1. All I do is I focus on that. I do the square root of 9, which is 3. Okay, that's under the x. See, so 3 goes with X. So I start with the origin, I go right 3 and put a point, okay, and left 3 and put a point. Okay, so and of course, though, you see those values right here that I got earlier. All right, now my Y values, I'm going to do the same thing underneath the Y. See a 4, the square root of 4 is a 2. That's going to go with the Y. So now I'm not going to put a point on there because I'm not going to actually get values there. I'm going to go start on the origin, go up 2, put a little X, down 2. All right, I'm going to draw myself a little box here. Okay. Okay, again, this is not the graph. This is just to help. In fact, let me do a dash line. Okay. Let's do it in red so it shows up. That's not showing up. Let's try that again. Erase this little mark I have. Alright, let's try it again. Okay. Let's make it green. Show it better. Alright, I'll make a little box. In fact, I know it's frustrating. I'll take the arrows off. Okay, so I'll make a little dash line there, and a little starting at this point, a little dash line here, a little dash line here. Okay, a little dash line here, and a little dash line there. Alright, a lot of work for a little box. Okay, so what does that help us do? It actually helps us find asymptotes. Okay, so this one is going to be for real. I'm going to make this one that'll show up. Let's see, I'll make it black. Okay, so from the bottom left corner of my box to the right hand corner of my box. And I can actually back up a little further. I see that, you know, from this corner to this corner I go up 2 and right 3. So I'm going to back up 2, go down 2 and back up 3. So I'm going to start my little asymptote right there at that corner. And from this corner I'm going to go up 2 and right 3. Okay, so that just helps the graph. So here we go. I think let's make it. Yeah, I keep changing my mind. All right, I'll make it yellow. Okay. So there's an asymptote, and the same thing. I connect the other corners. Okay. So from this spot down here, go through that corner. Remember, down 2 and right 3. Okay. So again, those yellow lines are not part of the graph, and those green, they're not part of the graph either. Okay. All right. But they're helping me do the graph. Okay. Here's my 2 points that are actually on the graph, right there and right there. What I do to finish this graph is I just go from here, curve it up like that, down there. Okay, just like that. Okay, up here this like this, up here like this. Alright, let me take these green dash lines off. Okay, because they help me, but now they're kind of a hindrance. Okay, take this other one off. Okay, and I'll even erase those 2 little X marks that helped me earlier. Okay, so there is my hyperbola. Alright, the last thing, characteristic. Now we can actually write the slope of these, and sometimes you're going to be asked, okay, what's the equation of this, this asymptote? Well, we went right, and we went up 2 and right 3. That means it has a slope of 2/3. And so I'll put X behind there, and it has a Y, and it goes to the origin, so it has a y-intercept of 0. So this line, this yellow line, has an equation of that. The other one would be very similar, except the slope is actually a -2/3, and it also goes to the origin. So sometimes you're asked to find the equation of those asymptotes. Okay, and I really should have put arrows at the end of these lines. Okay, I'll just try to draw them in. That should have had an arrow. Asymptotes go on forever. So I should have had arrows at both ends. So I'll put them there. And the last thing to do on a hyperbola is find the foci. Okay? So for ellipses, we actually took our two denominators and subtracted and did a square root. This time we actually add them. So you take a 9 and add 4, which of course 13. We do a square root. Let me try to approximate. The square root of 9 is a 3. The square root of 16 is a 4. So I'm guessing it's approximately 3.6. So where do I graph that at? I start at the origin. I go about 3.6. So I'll put a little X there for a foci. Focus is singular. So I'll put a focus for that X there. So it's about, if I calculate about square root of 16, square root of 13 correctly, it's about 3.6 and 0. And there'd be 1 on the other side. Start in the middle, go about 3.5. Okay, so that'd be the other focus. Alright, let's try one more. Okay, there's an old ellipse. I'm going to get that off there. Okay, alright. Let's try X. Let's reverse the x squared and the y squared. Y squared over 9. Let's leave. You're supposed to have the bigger denominator first on these. When you're doing ellipses, it doesn't matter. You know, when you're subtracting, oh, you gotta be, takes other things. Okay, so what would I do? Okay, well, I would use 3. I mean, square root of 9 is 3. Okay, so from this time I go up and down 3. Now, would I put a point there or not? Okay, let's think about it. Okay, would y equal 3 actually be a legitimate answer? Okay, so if I plug in 3 right there, 3 squared is 9. 9 divided by 9 is 1. I have 1 minus x over 4 equal 1. I'd subtract 1 from both sides. I get negative x over 4 equals 0. Multiply by 4. So I'd have divided by negative 1. Okay, so yeah, I'm okay. I'm going to put a dot point right here at 0, 3. Okay, let's make that bigger. Okay, alright, so 0, 3. Alright, so 0, negative 3 would also work. Okay, so what would my other 2 points be? Okay, well, look at the denominator of x squared. That should have been x squared. One more time. X squared. Okay. Alright. The denominator of x squared is 4. The square root of 4 is 2. So on the x direction, I go to 2. So I'll put a little x there. I'll put a little x there. Okay. Just like the last example, I'm going to draw my little box. Okay. So I'll put starting here. There's that. And then this one. And then this one. And this one. And the only purpose of that is to help us draw our asymptotes. So I'm going to put arrows this time. Okay, so let's see, from here to this corner, from the origin of the corner, I go up 3 and right 2. So I go up 3 more and right 2, I have another spot there. From this corner, if I go left 3 and left 2 and down 3, I have another spot. So I see where I can draw my asymptote. Starting here, go through that corner, go to the origin. Okay, and let's see, the other one. Start right here, go to that corner through the origin. Okay, so what would the hyperbola look like? Okay, so again, these yellow lines help us, and those green dashed lines. There's a point here, it goes sweeps up like this, sweeps over like that. Okay, and then down to the bottom like that. Okay, so let's take some things off. I'm going to take this yellow line off. This green one. That's just to help me do that, and you wouldn't have to do that yourself really, because you just have just a little thin little line most likely. Okay, I erase my two little X marks. Okay, alright, so there's my hyperbola. It's got two asymptotes, it's got two branches. Those are called branches. The curve, those are actually the graph itself, the blue, they're called branches. Okay, let's do the equation of this this asymptote. Okay, find the slope from the origin to this corner right here. You went up 3 and right 2 has a slope of 3 over 2 x, and it goes to the origin, so no y-intercept, and the other one's going to be very similar, but the slope is a negative 3 over 2. Alright, the focus. Okay, take your two denominators, add them up, you get 13, and I'll still say it's about 3.6. That's just kind of a guess. Alright, but this time I go up and down 3.6. So here'd be a focus right there, that blue X is. So 0 first and about 3.6. And down here be my other one, where that X is, that blue X. So 0, negative 3.6. Okay, I didn't talk about the numerators, but just a plain old y squared, plain old x squared, you know your center is 0, 0. Okay, what happens if your center, if you have a little more complicated numerators? Okay, let's try it again. Let's say just one more example. Let's say x plus 2 squared, subtract y minus 3 squared. Alright, let's make this a 16. Let's make that a 4. Okay? Okay, so what's the center? Now it's not 0, 0 anymore. Okay? You change that x, that plus 2 to negative 2. You change that negative 3 to positive 3. So 2, negative 3 would be the center. Of course, it's not part of the hyperbola, so I tend to put points where I find things, but I'll put a little X there, because that's not really part of the hyperbola. It just helps me get going. Okay, underneath the X, just same thing. I have 16, which is 4, so in the right and left I go right 4 and left 4. 1, 2, 3, 4. I'll put an X there. 1, 2, 3, 4. Okay. Okay, we'll figure out if that's a point or not. Underneath that y, I see a 4. The square root of 4 is 2, so I go up and down 2. I'll put x's there and y's there. Okay, so I think, well, we know actually the bigger number is front, so, and it's underneath x, so we know that actually on our x direction those are points, but let's make sure. Okay, so would I have a legitimate answer if I put in x equal 2? See, the coordinates right there are 2 and 3. Okay, when I plug in 2 for x, okay, 2 plus 2 is 4. 4 squared, let me get this other stuff off. Okay, if I plug in 2, Okay, 2 plus 2 is 4. 4 squared is 16. 16 over 16 minus, let me write the rest of this. Alright, 16 over 16 is 1. And we'd still have this. Alright, I subtract 1. Okay, I would have a negative y minus 3 squared over 4 equals 0. Okay, and so I could divide by negative 1, which is still 0, and I could multiply by 4, which is still 0. Okay, so what do I plug in for y? I could plug in 3 minus 3 and get a 0. So I'm getting legitimate answers here. So that tells me that's a point there, and that's a point there, which means these 2 points, these are not points. These are just to help me. See, in a hyperbola, you get 2 points, and that's really it. And the other 2 little marks are just to help you finish graphing. So let me build my little box again. Okay. So from this point through that little X over the other blue dot, and from here to here, and then down, and then down. So you make a nice little box. Your asymptotes, okay, they should have arrows. So let's see. Just to help me from here, I'm going to do this in orange so y'all pick up. From this corner to that is up 2 and right 4. Well, I don't have 4 to go left. Okay. From this corner, I can go up 2 and right 4. Okay, so I'm going to do it like this. Kind of go this way. Oops, I use my dashed line. Okay, so I'll start here. Go this way, goes to that center, goes to there, and it's kind of, just try to keep them. I did not do that right. Okay, because I have the wrong spot. I'll change this. Oh, up 2 and right 4. I went up, go right 4. So I should be over there. There we go. Alright, so let me try again. From this corner right there, goes to that corner, goes to the center, goes to this corner, and just stop somewhere over here. Okay, so I'm going to use, let's see, from this corner, go right 4 and down 2. Alright, so my other asymptote will kind of go like that. Now, I don't really see where it would cross over. It's really still approximation. Okay, so let's finish this up. Okay, so let me do this darker. Equation outline is y equal. Now you do have some spots you can work from, like from this corner to this center you go up 2 and right 4. So that slope is 2 over 4x. Okay. Alright, now it does not go through the origin, so I actually have to find the y-intercept. Okay, and well, fortunately that's very easy, because at the center I can go up. See, going up 2 and right 4 is the same thing as going up 1 and going right 2. So the slope of 2/4 is really reduced to 1/2. So from this center I go up 1, right 2. I see my y-intercept is 1, 2, 3, 4. So plus 4. And my other one I know is going to be the same thing. The y-intercept is not the same, so this time I go down 1 and right 2. So this, for this one, y-intercept is 2. And of course you wouldn't turn in a paper to this to somebody with 2 over 4. You say, well, that's 1/2 x plus 4. Okay, and the other one is same thing. Okay, so this one goes, is the equation of that line, and this equation is a graph of that yellow line. Okay, last thing, let me get a little more room. focus, okay, the foci. Alright, so you add 16 and 4, and you get 20. You do a square root. And again, I'm just approximating. I don't have a calculator on hand to get a really good approximation, but I know the square root of 16 is 4, the square root of 25 is 5, and 20 is between 16 and 25, so I'm going to approximate and say about 4.5. Okay, so how do I find my origin, my foci? I start with the center. I go right 4.5, 1, 2, 3, 4. So it's just a little bit. Oh, I didn't do my curves. Okay. Ooh, this graph's getting very messy. So let me clear this stuff off. Okay, so y'all can see we had a point right here. We had a point right here. Okay, I got this branch going up like this, getting close to the asymptote but not touching. Goes like this also. Same thing on the left side. Okay, my foci would be, so right about here. Start from the center, which is right there. Go right 4.5. I'll put a little X there. Start from the center, go left 4.5. So those two X's. So let me get the unnecessary stuff off. These green lines that help us do our asymptotes, we'll get those off. And we'll be done. Okay, so the coordinates are the foci, and I'm kind of just approximating. I don't have a calculator, so that'd be 1, and this other one would be about negative 4.50, and this line, this asymptote was y equal 1/2 x. Let's see, 1, 2, 3, 4 plus 4, and this asymptote is negative 1/2, and this x-intercept this time is a plus 2. And that's it. I mean, we don't do a lot of hyperbolas, but it's good to practice them every now and then.